Hey everyone, my name is John, software engineer with 10 years of experience, and I'm walking you through my layoff journey as a senior software engineer, recently laid off in tech. One of the main pillars of my job search preparation is practicing Leetcode. Part of that involves the laterally Leetcode kata. This is a standardized, evidence-based coding round whiteboard interview preparation approach. So I give you this fixed set of 12 problems called the laterally Leetcode standard kata. And then there's an extended set of 20 problems if you want to go for that. This will cover the majority of expected whiteboard algorithm interview questions. And so it's a practice-based approach, memorization, do a little bit every day. And yeah, so this is day number, I don't know, 5 or 6 of doing these over lunch each day. So without further ado, let's kick off, and we'll do this for as many as we can get through in an hour. And then I'm going to go take a nap because I'm tired. All right, so we'll start with two-sum. 167, the input array is already sorted. Given a one-indexed array of integers called numbers, which has already been sorted in non-decreasing order, let's find two numbers such that they add up to a specific target. We want to return the indices of the two numbers added by 1, so the one indexed indice of the number. We'll return this as an array or a list. It will always have length 2. And the tests are generated such that there is exactly one solution. We shouldn't use the same element twice. We don't need to worry about having multiple solutions. We don't need to worry about having 0 solutions. We do want to make sure we use constant space. Given that numbers is already sorted, intuitively, I should use a window or pointer algo. Let's break that to a new line. In the worst case, I need to check every element in numbers. So target time complexity is O of n. Pointers take constant memory. So space complexity is O of 1. Okay. So with the two-pointer approach, I'll initialize left to the far left of the array, and right will be the far right of the array, which is the length of numbers minus 1. These are the 0-based indices, and so we will return with 1 added. We'll eventually find some ideal left and right. We'll eventually find some ideal left and right, and we will want to make sure that we add 1 in those cases. So how do we know that we have the ideal left-right? We want to get the current sum. So we're starting out on the edges. And what is the sum of that? We'll figure out that sum, and then we'll manipulate that sum to get as close to the target as possible. And indeed, we're guaranteed that we'll always hit the target in this case. So we'll converge until we hit the target sum, and then we'll return. And we don't need to worry about the case where we find no such target. So the current sum is numbers, the left index, plus numbers, the right index. That's the current sum. Say if cur sum is less than target. In this case, we want to increase the current sum. So we should move the left pointer up. Else, if the current sum is too low, sorry, that was the case where the current sum is too low. Else, if the current sum is too high, we want to decrease it by moving the right pointer leftward, so that the right is pointing to the highest number. So by moving to the left, the total sum is it could potentially stay the same, but then you'll just keep moving. And so eventually it will decrease. Eventually it will decrease. Could potentially stay the same because it's non-decreasing order. So it could say like 1, 1, 1, 1. You can have duplicates in a row. All right, so this is right is minus equals 1. And then otherwise we have a match. Okay, and we already have the return expression. Let's just make sure it's indented properly. So this looks correct. Let's test it. And we have solved the 2-sum. Now we'll move on to 3-sum. Let's get a W in the chat for that 2-sum solution A. Wipe out the prior solution and I'll put it to do. And we'll read the prompt as if it's being presented in an interview presently. Given an integer array nums, return all of the triplets like nums I, nums j, and nums k. So these are values such that I is not j or k. So those indices are distinct and they all sum to 0. In addition to the indices being distinct, the solution set must not contain duplicate triplets. So here we have the word set, which in Python correlates to a set literal. JavaScript and other languages also have a distinct set literal, which is distinct from the list or the array, which was used in the triplets syntax and also being used here in example 1. In example 1, we can see the output is a list of lists of integers. So there is an ambiguity on the return data type. So what are we to do about that? I believe we can return any of the above. And if I were in an interview with a interviewer, I would just confirm with them. Is it okay? Like, do I have the freedom to return list or set or array? Can I choose whatever data structure I prefer, or is there a particular one? We also do need to deal with the possibility of, in example 2, an empty output and multiple potential outputs. So I will prefer a set for deduplication on the tuple. In Python, you can deduplicate tuples automatically in a set, which is an advantage over the list approach. So I'll say results is a set for automatic tuple deduplication. And my approach is take an optimal 2-sum and wrap it one level with an index, like integer indexed array. With an integer index on the nums array. That's clearer. Performance. So this requires a sorted nums, which takes in log n, time complexity. This is not binding on the O(n) squared complexity of wrapping 2-sum. Memory complexity is constant because it's just pointers. Okay. What's the new project? Nothing new today. We're just going through the old Leetcode kata. Practice makes perfect. So here I'll do an outer left IDX and set it equal to 0. Then I will make sure to sort nums. And we'll say while that outer left IDX is less than length of nums minus 1, while we're in bounds, basically, we want to get the complement. We want to call 2-sum, and we want to fast forward duplicates. Then eventually we will return results. Isaiah over here on YouTube. Thanks for being here, Isaiah. Good to see you. Whether you're on YouTube or TikTok or another platform, I'd appreciate if you can like the video. That will help the algorithm send the video around to other people who may be interested in learning about Leetcode. You have software corporate. No, not currently. Okay, so here we will get the complement. The complement is the opposite of the value at the nums location for the outer left index. The reason it's the opposite is because the complement means that thing which adds to 0, that thing which adds to 0. And we need that because that will become the two-sum target, so that when we have the two-sum target met between those two, and then the complement met by the outer left index, now we have a triplet that adds to 0, which is the requirement. So this is going to be the opposite of the outer left index of nums. We'll call self.twosum. And then we will fast forward under two conditions. First of all, we need to make sure we're in bounds. So that's just repeating this already existing expression. And the second thing is we want to fast forward when the complement is unchanged, because it won't change our tuple result. So why are we calculating that over and over, calling twosum, which gives computational intensity? And so we can fast forward or skip those cycles whenever the complement is equivalent to this. I'm in Python, so the double equal sign is fine. No need for triple. And notice that this will always hit at least once. It's guaranteed by construction to hit at least once, but it might hit more. It might hit more than once, and so that's where we would get our time performance benefit. Here we're defining twosum. What are the arguments we need for twosum? It's on the same solution class, so we have to pass self. We care about the list of numbers. We care about the results set. Is it results with an S or a result with a single T? Results with an S. We care about that complement. We care about that outer left IDX. This complement, we'll just treat it as the target inside of twosum. I think that's everything we care about. If I'm missing something, we'll find out. So now that we're doing this inner twosum, from the perspective of the inner twosum, we're exploring that window that's to the right of the outer wrapper. So eventually this will collapse. That's how we know we've explored all possibilities, all combinations. While I'm in the context of the twosum, my left will just be initialized to the outer left index plus 1. And right is going to be the same rightward bound, which is the length of nums minus 1. We'll use that familiar left-right crossing condition. Once they cross, there could be no further options. They'll just be the opposite of the, you'll just be getting duplicates of what you had anyway, right? So if I'm pointing at the far left and the far right and then I add them, let's say I eventually cross and go all the way. Well, they're still going to add to the same number. So there's no sense checking those things. That's why this is the boundary condition. So the current sum would be the left of nums plus the right of nums. And we can see if it's above, else if it's below, else. In this case, the match is found. Match on target is found. Let's append, not return in this case, because we could have multiple answers. A sorted tuple to results. So sorted tuple will be the opposite of the target. That's going to be the value at outer left index. You could also just say outer left index of nums. They'll be equivalent. And then here I will say cur left, cur right. Then I'll say results dot add. Is it add or append? And then here I will fast forward. Just like we fast forward at the wrapper level, we also want to fast forward here. But here we're going to fast forward on left or right. You can pick either. Perturbing either will work. I'll perturb left. It's just consistent with the overall mental model that we're moving left to right. Thank you for the likes. Okay, so we're fast forwarding the duplicates, and we need our boundary condition to make sure that we don't go out of bounds, and we need our cache condition. So here, I said that cur sum is left plus right. That's fine, but we can extract that. We'll extract it because we don't want to repeat ourselves. And it improves the readability a little bit. We extract right for code consistency with left. And then the above condition, that was a pseudocode. The real condition is that the current sum is greater than the target. That's what we mean by above. The cur sum is less than the target is what we mean by below. So when the current sum is too high, we want to decrement the sum. And the way we decrement the sum is by taking the right pointer, which is pointing to the higher value, and moving it to the left. Okay, so we have our current sum, we have our above and below adjustments, and now we have this match condition. So we want to append the sorted tuple, and I might switch it to add if I get an error on that append method name. Okay, results while left is less than right, and also while the cached value is unchanged. So we're perturbing left, which means we should do our cache check on cur left. So and cur left is equal to the left value of nums. We're going to keep incrementing left until that cache is busted. Then it's worth us doing the recalculation. Does that make sense? Thank you for the likes. Over 400 likes on TikTok. Thank you so much. Okay, so let's run this code. We get an error. Object has no attribute to sum. Okay, so this could be a famous Python indentation error. Yeah, so let me dedent to sum. Now we're missing positional arguments. Okay, so we called to sum, we didn't pass this data. Let me grab these argument names. Double check the names, nums, results, target. It's not called target here, it's called complement here. So nums, results, complement in the outer left index. Now I have everything. And there's no such method as append. Okay, I'm getting my languages mixed up. So this is called add. There we go. All right, we're at the 18-minute mark, and we've done 2 problems plus the introductory boilerplate on the stream, so that's great. By the way, you can visit Laterally, sign up for free. You can join the Discord and ask your questions away after the stream at that Discord. The Leetcode kata I've been performing, you can see it here, and then there's also solutions in article number 7. So this will help you with your coding round. You can also learn about building projects using article 2 and article 11. Improve your resume. By the time that you have a solid resume, solid portfolio projects, your Leetcode, you're getting well into your job search, and that might be enough to land you a job at many companies. But if you want to go further and study behavioral interview, then subscribe to the channel and watch the stream later today. I'll be building a custom GPT for simulated behavioral interview. And that's basically the latest and current thing that Laterally is working on, is behavioral interview preparation. There was a stream earlier today, and there will be another stream later today. So I hope you'll stick around for that. Thanks for being here. And thank you again for the likes. It looks like we're now at 1,000 likes. That's wonderful. All right, let's continue with the next Leetcode problem. So after 3 sum, we move into longest substring without repeating characters. Given a string S, let's find the length of the longest substring without any repeating characters. In one example, we can see that the output is 3, so the return value should be an integer. Indeed, it should be a non-negative integer. And the answer is 3 in this case because ABC is the longest internally unique substring. Notice that you can repeat ABC, so it's not externally unique. It's not unique throughout S, but it's internally unique. That is, A, B, and C are distinct characters. And then in the case with all the B's, your longest collection is only 1, right? So that makes sense. Can the string itself be 0 length? Yes, it can. So we could potentially have a return value of 0. Because there's a potential return value of 0, I think I want to initialize my result to 0, and then we can do a global maximum, like a cached maximum, where we'll iterate through S and we will recalculate the current valid substring length. And then the longest valid substring length will always be the maximum of that which pre-exists from the prior iteration and then the current state. Okay, so that's the overall approach. And in the worst case, I'll need to scan every char in S, every character of S. Because in the worst case, they're all unique. Like ABC, I need to look at all of them to find out that the value is 3. Okay, so time complexity will be that. And then the memory complexity will also be that, which is to say O of n, because I potentially need to store every character to make sure that I don't have any duplicates. Approach is to use iterative max on a global cached int. Time complexity is O of n because I may need, it's not better to say may, it's better to say I do need in the worst case. I need to check every character in the worst case. Space complexity is O of n in the worst case for unique checking. Okay, so result will initialize to 0. We'll eventually return result. And then here we'll say while in S, and that's a pseudocode, cur validated substring length is 0. That's a stub. And then result, this is going to be the global cached iterative max. This will be the max of whatever it was previously and the new one. And it's important that it's validated. We don't want to get the length until post-validation. So validate. So we'll get cur substring, and then we'll validate, and then we'll get its length. How do we get its length? There's a couple ways to do this. I think we can use a left and right pointer. You could also have a different string cache. Oh, I can use a left and right pointer. Space complexity is O of n in the worst case for unique checking. We can do space complexity O of 1 with pointers instead of a cache. Okay, so let's do left and right pointers. Right. Yeah, they're not going to be initialized to the left and right of the whole thing. They're both going to start on the left hand, and then they're going to move. So the approach, this is a sliding window approach, basically. This is a sliding window approach. So they're both initialized to 0. So we'll say left is 0 and right is 0. So now we're just using pointers. And so now the current validated substring length is right minus left plus 1. This assumes that we got and validated right and left. And here, I can say for char in S. So now we're looking at every character. I'll immediately increment right. Left, we're not going to increment until we have to. By lagging left, we're maximizing our window. Like if I move that right and the left never moves, it keeps getting bigger and bigger. And we want to get the biggest one possible, our window, our sliding window. So I'm only going to move left if I have to. So it's a lazy left. We have an eager right and a lazy left. Okay, so here I've incremented right. And then let's see, there's char. I already have char. Okay. So how do I know whether to move left? Do I still need a cache? No, because it's an off by 1. If I ever run into a dupe, I will just move left until the dupe condition is eliminated. So I only need to consider one character at a time. So here's the character. I don't know if that's true. Yeah, I think that's true. So it's only a problem if right and left themselves are dupes. I don't actually need to consider the intermediary characters because I'm starting both at 0 and I'm considering one at a time. So I'll always know. I'll always know. Okay, great. So right plus equals 1. And then if the left character, if the left in S is char, left plus equals 1. How about that? What do we think about that? I'm trying to avoid using it like a scene map or anything like that. So I move my character to the right. And then if my left one is this new character, I need to move left up. Let's see. Maybe. Let's see. Okay, that's wrong. So let's look at a test case, ABC. So they're both on 0. They're both pointing to A. Now right goes to B. Okay. S left is char? No. So we just get the validated substring length, which is going to be 1 minus 0 plus 1, which will be 2. 1 minus 0 plus 1, which will be 2. So why is the output 1? The output should absolutely at least be 2 for char and S. Okay. They're both starting on A, and like at every point they're duplicate of each other. Yeah, that's a bummer. So I could start them staggered. I could start them off by 1 from one another. Let's do that. Now I need to handle the case where S is length 0 or 1. Okay, so now we're guaranteed to always have 0 and 1, so I can start staggered. Now that I'm starting staggered, I shouldn't use the for char thing anymore. Now I should say while right is less than length s. That way I don't go out of bounds. And here I'm eagerly, so here I'm assuming that they're not identical. I don't want to do that. Oh, there's another way to do this. I can just say if left is char and left is not right. That would be an easier way to do this. Let me go back in time and get rid of my edge case handler. I'd prefer not to need to have special logic on the 0 and the 1. Okay, so if the left character is the right character, but the indexes are different, then I need to change my left index. Okay, so that still didn't work. Let me see what prints here if I debug it. 1, 2, 3. Right, so for char and let me not use this for n. Let me still use a while. While right is less than length s. String index out of range. How did that happen? Less than s minus 1. Now I've got 5. Interesting. So I'm at 0, then I'll increment to 1 and pick B. 2, 3. So we have 4 minus 0 plus 1. Good. Okay, so now we're getting to 5, which is the substring length. If I hadn't moved left. So it's as though left is not being moved correctly. Let me move this right. What if I start by getting the character? So I start by getting the character, they're both on A, and then I say, hey, if you're the same with different indices, but they're both on 0. So now I'll increment right. Nope, that's the wrong thing to do. I do want to eagerly increase right. Zero, 1, 2, 3. 0, 1, 2, 3. So I move left and I move left, and now left is 1. So 3 minus 1 plus 1 should give me the expected 3. Let's print all of them. So we have left, right, and char. Okay, this is the issue. The char be twice on the right. So I could have a priv pointer on right. But how much distance would there be? So it could be BA. Yeah, I do need a cache after all. Okay, so I need the cache after all. We can do a space complexity of 1 with pointers instead of a cache. Oops, no, we can't. We need a cache. So space is really O of n. And I'll check this after I implement. Let's get the implementation done first. So here I'll have scene, which is a set. And then here I will say scene.add char. And instead of this condition, I'll say if char and scene. And then here I will scene.remove the left character, I believe. So we're going to move left and we'll keep purging left. Those will always be unique. Key error P. Okay. And left is not equal to right. Key error P. So 0, 1. Okay, so I never added the 0 is the problem with this approach. We could try special handling 0. I don't really like that, but let's just see if that works. So scene.add 0 of s, if s So if the length of s is 0, we'll just return 0. Otherwise, let's go ahead and add it. And this works in 2 cases, and it fails in this case. Let's see, why is that? Oh, I guess this should be while, not if. Okay. Let's see if that passes. An empty string. What is the length of an empty string in Python, is that 0? Why did this happen? Let's see. I don't think this is the root cause. Well, let's just see. Okay, yeah, that length there is still 1. Is it just, okay, it's just a special case to do with length 1. All right, so this works. I don't like it though. I don't like that I need special handling on length 0 and 1. This works. How can I eliminate the special handling? Oh, also we can make it faster by eliminating the print there. So now we're faster. That's good. Got to get all the base cases. Yeah, I mean, this does have base case handling, but it's just like, it's like a special handling. I wish I could handle it cleanly in the loop. And I think there is a way that I can do it if I rewrite this while. So how about a for in range instead? For, what would it be? Right in range, length s. So instead of a while, I'm going to say for in range. Now I don't need to increment my right. Okay. And also, if s is length 0, it doesn't enter the loop at all. So I don't think I need the length 0 thing anymore. I'll double check about 1. But if I go this way, this line will be bad now. It's going to actually include the right in the for in range. So let me comment that or get rid of that. Okay. Okay, nice. A little bit faster, a little bit better, a little bit cleaner. This is pretty good. What about that len1 case? Can I get rid of that case? Let's just see if it's already included. Let's just see if it's already included. Oh, that's cool. Oh, look at that. Whoa, now we're really fast. Now we're on the left side of the mound. There you go, people. Miley Cyrus said, it's the climb. It's the climb on that Leetcode performance mountain. It's the climb, baby. Okay. Thanks for the likes. 1.1K likes. I appreciate it. I like you back. So this seems like a good solution. Is there anything weird about this? If left is not equal to right. What if they are equal? Can I get rid of that bit? What if they are equal? If they are equal, then I shouldn't be removing left, but it won't happen. It won't happen because it never was added, because in the worst case, we're on 0 here. So let's check this. Let's check this. Look at that. Still works. I think that's about as clean as it can get. Okay, we'll call it there. That took longer than needed. That took like, now we're at the 44-minute mark. So that took like 15, 20 minutes by itself. That's okay. Sometimes it happens. Now we're going to go for the linked list cycle. Hold your breath. And we'll, each and every time, it doesn't matter how many times you've seen the problem, we are going to try to clear our mind and read the problem as though it's the first time that we're seeing it. This will help us build resilience to being presented with new problems, and it helps us build the practice of proper interview etiquette. Proper interview etiquette is not, I've seen the problem, so I just start coding. Proper interview etiquette is you read the problem, you clarify questions and assumptions, you go over the return data type, you talk about the time complexity, the space complexity, pseudocode, then code. And so part of our kata, the point of our kata is we're not speed running. When you do the laterally Leetcode kata, you are not speed running Elder Scrolls, right? Like you're not speed running Mario, but you're not speed running any video game. You're maybe slow running. You're slow running it. Maybe not slow running. I don't like that either. Don't be slow. Just follow the etiquette, follow the practice. That is the point of the kata. Okay. Given head, the head of a linked list. Determine if the linked list has a cycle in it. And we can see from the data type annotation, this is a singly linked list. We have next, we don't have a priv. We don't have a back button. So there is a cycle in a linked list if there is some node in the list that can be reached by continuously following next, basically like an infinite loop. So you're following along a line and then you get into a loop. Boop, boop, boop. It has a cycle. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Not sure why that's relevant. Thanks for the info. Return true if there's a cycle in the linked list. Otherwise, return false. So return true if there is a cycle. And the method is called hasCycle. What a beautiful function name. Here we can see in example 1, we want to return true because 4 points at 2, and you get in a cycle this way. All right, and then in the case of 1, there's no cycle. So what's my intuition here? Intuition. I could cast to a list. This takes O in memory with O in time complexity. Then I would check what? If there's an end of the list. Then I would check if it has a finite length. The problem is this would time out. This would time out. In casting, because sometimes. This would time out in casting sometimes if there is a loop. Okay. Approach 2, I can cache all the scene nodes. And if I hit a scene node, return true. Cache takes of n space. Final approach, let's use fast and slow pointers. If they collide, there must be a loop. It is as fast as option 2 with time complexity O of n, but constant memory. Jonathan says, can you add fields to the node a visited property? The answer is no. In this form, as written, we should preserve the singly linked list nature of the structure. We could create some copy so that there are new elements that are created external to this structure, which do have back and forward. So we could like create a doubly linked list copy. If we do that, we're creating a copy. So it takes the O of n memory anyway. Does that make sense? So that's kind of equivalent to creating the list, like the first thing I said. And it has the same problem. Like if you want to create a doubly linked list copy of the singly linked list, at your copying time, you might run into an infinite loop. But caching in its own set outside of the list gets you the same information without the infinite loop. So instead of adding the visited fields to the node, you can have visited as an external map, like seen visited. This is the same concept as the cache. And so that solution works, Jonathan, but it's not optimal. And it's not optimal because you can get the same Boolean indication with less memory cost. So that's why this final approach will be a little more optimal. Great thought, though. Thanks for being here, by the way. Let's make sure that we're set up to return the right value. So it's just going to be a Boolean. It's just going to be a Boolean. Do we want to initialize it? So in this case, we're going to have a left and right pointer. We'll call them fast and slow. So fast is kind of like our right pointer. They start at the same place. And what's going to happen is if I get to a terminal node, I don't have a loop. And if I don't get to a terminal node, I do have a collision. So I will have a complete while loop. So I don't need to have a default Boolean return value, and I don't need to return or handle outside of the while loop. It is a complete while loop. It handles all cases internally. I'd use invariance in my linked list to not allow loops to start. Yeah, if you're making like a coding project, that's a good move. But this is like a Leetcode. Okay, I agree with you. Leetcode problems are very often contrived and not reflective of the real working environment. This is like a very true, very valid criticism of the Leetcode game. Okay, so the while loop is internally complete. And so what is the while condition? The while condition is while there is a node to traverse, like while next exists, while cur.next. While cur.next. So we have this next pointer. Oh, you know what? This is not true. So if while.next is false, we break out of the loop and we want to return false that there is not a cycle. So the internally complete thing is actually a lie. At least it's a lie if I'm using this while condition. I could contrive some other while condition that would make it complete, but I think this is pretty clean. So we might return true internally, and then if we break out, we're going to return false. So what is cur? Cur is fast. Cur is fast, and I shouldn't use indexing. I shouldn't use integer indexing. Instead, I'm just going to have fast point at head and slow point at head. And when I say cur is fast, I'm just going to say while fast.next. While fast.next. So here, I'll say fast equals fast.next. Fast, and then I'll check it again because it's called fast because we're incrementing twice if possible. So if fast.next again, twice because this is the fast moving pointer. You could do this multiple times if you want. You could have in nesting. You could say, you could do it 3-in-1 ratio if you want. So if fast.next has another next, this is the grandchild node, then fast is going to be the grandchild node. And then else we'll return false. Okay. So now we have iterated fast twice, and now we will iterate slow. So slow is slow.next. And we don't need to do any null checking there because fast went out ahead, and we already know that slow is allowed to traverse. Now we just need to say if fast is slow. So fast is going so fast, they're running on like the quarter mile in middle school, and now they're lapping you. And so this is going to cause a collision where they might point at the same node. So if that's ever the case, that is the condition where we know that you got lapped. It was a loop. There's a loop. So we'll return true. How about that? Great. None type. What happened here? I'm missing some check somewhere. So while fast.next, okay. I said okay, and then I totally lost it. I thought I was going to need to do this. Thought I was going to need to do that, but that shouldn't fix anything. Yeah, that doesn't fix anything. So the issue is when head is none. That's the issue. So the issue is when head is none. So I'll say if not head, return false. Yeah, okay. Maybe the guard is like a little expensive. And so that's why we're on the right side of the Miley Cyrus's mountain, but I'm okay with that. Let's try and move it down. Let's just run it again. Sometimes you just run these few, and there's like natural stochasticity. So we got 50 milliseconds. We got 48, 37. Okay, it's just natural stochasticity, like natural performance variation. But we're going to say that this ran in 37 milliseconds because that's the fast benchmark. And that's how you game statistics. We increased performance. This is like your behavioral interview, right? I increased performance by 20% by pressing the submit button more times and cherry picking my data. Okay, we have 2 minutes. Do we have time for one more? Probably not. Palindrome linked list. Are y'all going to make me do this? All right, let me get a dub in the chat if you want me to do it. If I get 2 dubs, I'll do it. Here you go. You got 30 seconds. I'm going to sip on my drink and take a brain rest. And if we get 2 dubs within the next 30 seconds, or I'll just wait till the minute mark sort of ticks. Otherwise, we'll call it a day. Oh, we got 1. Okay, let's see. 22 seconds to go. Let's see if we get 1 more. Myth and Mirage, thanks for being here. Oh, TikTok did not carry today. All right. Well, with that, I'm going to go take a nap then. Thanks all for being here. Follow the channel. I'll make sure to get to Palindrome linked list tomorrow. You know, unless I'm like feeling sick or something like that. But I'll plan on trying to get through Palindrome linked list tomorrow. I'll try to get to clone graph tomorrow if I'm feeling it. Tune in and find